In the previous video, we calculated the area which was bounded by our function fx and the x-axis. And the area was given by this formula where we write the sum from a to b, because we're looking at this only the area from a to b of this function fx dx. And notice that in this formula we're ignoring something important, and that is the x-axis. The x-axis is given by, say, y is equal to gx, and that is equal to 0. So if we continued writing this formula, we should have said it's enclosed between fx and gx and written a, b, gx, dx. But because the function gx is equal to 0, we didn't need to write this in, as this whole part will just automatically be 0. But now let's look at an area that is bounded between that same function fx and another function which looks more like this, and we'll call it gx. And I'm interested in the area between a and b intervals. So you notice now that there isn't an x-axis, but we've got two different functions. Our calculations will now need to take into account the function gx, but we need to now decide which is the first function and which is the second function. Now, because the gx is now considered to be the upper function, we'll call it the yu, and fx is going to be now the lower function, we'll call it yl. And so our area will now be from a to b, the upper function, take away the lower function. And we can write this in brackets, dx, which just translates to this gx from a to b of gx, and to take away the fx function in brackets. Well, in determining the area between two functions, you need to determine which is the upper function and which is the lower function. I'm going to give you one other example in here. Okay, so to find this area bounded by the x-axis and another function x squared minus 2x, you're going to have to find out where the curve cuts the x-axis. Now, the x-axis is given by y is equal to 0, and your curve is given by y is equal to x squared minus 2x. So we need to find out where it cuts the curve. So we will equate the two functions together and find where the x-intercepts are. So that's going to be taking out the x out. We leave x minus 2 is 0. And we know that therefore the x-intercepts are going to be at x is equal to 0 and x is equal to 2. So we're looking at an area which is bounded by 0 and 2. But which is the upper function and which is the lower function? You need to first of all draw the curve. And you might have used a graphics calculator to draw these two curves, but we know that it'll cut at 0 and we know that it'll cut at 2. And now we're able to see that what we want is the area below the x-axis. So that means that our x-axis is going to be the upper function. So that's going to be the upper function, And the blue function here is going to be the lower function, and that is x squared minus 2x. So calculating the area now is simply writing the area, and we're calculating this area between 0 and 2, and we want to be doing the upper function first. So we do upper function, take away the lower function. Okay, so that's dx. And what do we know about the upper function? The upper function is 0, so we will just put 0 down there. And the lower function is x squared minus 2x. And that whole thing can be integrated with respect to dx. Just to simplify it, we don't need that 0 anymore, so let's just take it away, and we'll find that we've got minus x squared minus 2x. And can you see that negative sign? Well, we want to get rid of that by rewriting this 0 to 2 and saying 2x minus x squared. Now I want to start integrating this, so I'll move to the left over here, and in square brackets 2x, it is 2x squared over 2, and x cubed over 3. The 2 will cancel out, and we're doing it from 0 to 2. Alright, so this just becomes the next step over here. Now, we're going to substitute not the 0, but we're going to substitute the 2 inside first. Alright, so everything on the right hand side is 0. I didn't have gone through all that trouble, but I just thought I'd do it anyway. So simplifying is 4 minus 8 on 3, which is 12 over 3. Take away 8 over 3. Clearly that's 4 on 3 square units. Or should I say just units squared.